my co-speakers, eminent dignitaries, industry professionals, ladies and gentlemen. A very good afternoon. So, what Dr. Gupta said, we had a chat a month ago, or 1.5 months ago about this. And that's when I realized that I was not expecting this after changing my organization so soon, that I'll get an opportunity to talk about something entirely different for me, at least in the field of subsurface oil and gas. So out and out, I've spent my entire career of more than 2 decades in conventionals. And for the last 2.5 months, I'm on the extreme other end of the energy spectrum, I would say, in subsurface, which is coal bed methane, CBM. It is really interesting. It has taught me many things, even in the short span of time. So what I'll do is, I've attempted to showcase or share with all of you, these are all public domain data, but to summarize that what in the field of gas today, in our aspiration of being a gas-based economy, what we are doing in the field of coal bed methane, which is both from physics point of view, from subsurface point of view, it's different from the conventionals. This is a brief outline. I'll try to cover up in this 8 minutes what I have. So first of all, CBM, which is coal bed methane, we call it in this part of the world. But if you go to down south Australia, it's known as coal seam gas. And we all know about the LNG, the huge mammoth production which is going on from Australia. That's completely from coal bed methane or coal seam gas. Then I'll talk a little bit on some of the key parameters and enablers which our country are playing a big role, Government of India, to enable this to happen. And briefly then on to a case study, which is our Raniganj block, what we are doing and how we are using digital to be more efficient in this process and going forward. So it's a busy slide, but more or less, what it says is of our vision of going to be net zero, and we heard about that yesterday also a lot. And there were some very pertinent comments made at the inaugural address by Mr. Azdan is the deadline that we have set ourselves for 2030, 2070, how 2070 looks to be a more reasonable target and reduce our emissions to a large extent by 2030. Though CBM is a minor player here, but I think it can be a game changer as well because of the very simple fact that we are the 5th largest coal resources that we have across the world. So that's something really intriguing, so that we can utilize this coal, which is not mineable, which are deeper than 700,000 meters. How we can utilize that to make it more cleaner, first of all, and secondly, add to our gas-based economy. So that's what it says over here with the data from the Indian Energy Outlook. A little bit on how we fare as on date today in the field of CBM across the world. It's a no-brainer. All of you can see that in India, the graph is almost not there as compared to the world. But I see that as an opportunity. That's because the amount of resources that we have untapped in our country. So we have to break that, especially in the deeper CBM, in the deeper coals. What we are operating in our block in Raniganj is 700, 800, 900 meters. But there's a vast amount of resources in our block untapped, which is in the deeper seams. Yes, permeability will be a concern. So horizontal wells, laterals, multilaterals, fracking, all these things will come into play, and technology. So technology here again, digital and technology is going to play a big role of how we untap that particular potential. We all know, like apart from us, a lot of our colleagues are also there in this, especially in the CBM. It's mentioned over there. And unlike conventional, I am really proud to be a part of this particular consortium. Is everybody is trying their best to extract as much as possible efficiently from coal the CBM. In the sense, we had a conference just few days ago in Bhopal organized by MOPNG, and there also all the operators, they are trying everything to unlock this potential. I just spoke about this. These are all supporting the fact that, you know, we are reasonably in the learning curve. We are in that phase. Gas evacuation infrastructure is coming up big time. So as a country, the government is really helping. The Urja pipeline, everything has really a big enabler, especially for us, for Essar Oil and Gas. We could untap or unlock our potential big time after the pipeline was commissioned. So that really helped us. So all these levers, catalysts are working. So it's for us now to make it work. That's what I'm trying to say here. Just 1 minute on the technology or the basic. Actually, this is not a technology. This is the basics of CBM. What difference it actually is. So first of all, it's the source itself. Coal itself is the source. Unlike sometimes, a lot of times in conventional source is somewhere else. The reservoir is somewhere else. The basic storage mechanism here is adsorption. Unlike in conventionals where it is under pressure, it's in the matrix. And two particular processes work here: adsorption and disruption. So basically, we want to depressurize the reservoir here, which is again a bit counterintuitive from sandstone or conventionals. You want to maintain the pressure, sweep, but here we want to depressurize as fast as possible, produce the water, and the gas is going to come behind it. So typically, any CBM profiles, what we see is it's heavily loaded at the tail. So first, the initial production will be a lot of water, and then the gas kicks in, gas breaks out. Unlike any tight reservoir also or conventionals, it's all front-ended. So that's why it is so important for the country to help from policy and other tax and other regimes to help the operators, because otherwise commercially it's a very difficult proposition when your production is all tail-ended. So we are fortunate that India, in our country, the policies are favoring. They are trying to help. So we need to break this shackle of untapping the subsurface. I will skip this one, or this is basically says that how gas comes out from the coal CBM and it draws into the wellbore. So basically two laws works here, not only Darcy. Darcy is typically when it comes into the wellbore, but before that desorption has to happen from the surface, and then it goes into the cleats or the fractures in the coal when it comes to the wellbore. Okay, this is how we have been developing our Raniganj field, as you see over here, right from 2002. It's a long journey. I have just joined, more than 350 wells drilled. It's a pad-based drilling, very simple, pad-based, produce water and gas from the same well, and we collect it in in central processing unit and put it in the pipeline. Okay, 2 minutes I'll take over here is on the technology part. So as like any other reservoir, the process is same. The subsurface modeling, geological correlation, petrophysics, reservoir engineering, it's all the same. The only thing here is what we tried to do is, we don't have any seismic in our block. For that matter, in India, in CBM, there very less seismic is there. A couple of 2D lines are there, very sparse. We are trying to do that. So it's all based on wells. So that integration of well data along with the production data, we have used a lot of algorithms and a lot of pattern recognition to come up with our production profiles, and that's where digital has really helped us. Today in the last session I heard, we actually are digital for a long time, from 90s, which is a fact. In subsurface domain, we lived and everything was digital for us, right? Without that, we could never imagine. I'm talking of post-90s. So we have been trying to use that as much as possible in absence of any seismic data to maximize our development campaign. Little bit on production optimization, how we have been using digital, and as I said, bringing together all the hardwares and the software and the communication system into a single platform. That has been done in the Raniganj field. So the different domains, right from mapping to our artificial lifts in the pumps, to flow measurement, reservoir monitoring, bottom hole pressures, and control system. So all these were integrated in the digital oil field that we operate today. and it's giving us actually very good results. So I will skip the animation in the interest of time. So what it basically says that how iterative this process is. After we get the well data, the performance curves, and then we update the network model, analyze it, and again put it back into the system, which goes into my predictive maintenance or any well intervention or pump change out. So this we have been using day in, day out. And this workflow, every workflow is different for different companies based on their field, based on their wells, based on the nature, on the operations of their reservoir and their wells. So this has been designed in-house, this workflow, I would say, and been using all the tools in the market, commercial market, to maximize our reservoir monitoring, I would say. This is again pretty standard in our current industry in conventionals as well, the digital platforms, digital oil field, we use SCADA as historian, and we use that a lot for our production surveillance as well. I'll show you one example onto this. In the interest of time, I'll go there, and that's actually interesting. So, right, let me talk over here. This is how a classic example had helped us in optimizing our production. So the curve on the left, on the upper left-hand quadrant, that's a well behavior. So in CBM, what we monitor is water production, our pumps, torque, and the gas rate, obviously. So what we saw is we always have to take water level measurements, because that's very important for us. Water is a friend in CBM. And the easiest way to do is doing eco shots. It has been done in other wells as well. So it's very cheap, very simple. You go there, you do an eco shot, you understand the water level, and based on the level you design your pumps to extract that water. Now what we were doing is, based on the eco shot, which is the blue curve, we could see a certain level of water level. And based on that we designed our pumps, and again our pumps on the curve below now, if you see, the red one is the gas breakouts and the gas production. We were having the pumps getting dried out. So that's when we went in and put in real-time gauges using digital, again it's digital. And we understood the data, what it came out is the water level is actually much lower than what we were getting from the eco shots. And based on that, we could resize our pumps in many other wells as well. And we had gas breakout in a couple of weeks or 2-3 weeks just after that. So this is one example I'm sharing. There are multiple examples of these type and many other options wherein we could utilize more of digital technology to optimize our field production and our reservoir management. And going forward, we are really pushing hard to do much more on these aspects. I thought to put a last slide, apart from digital, the key things, the key technological interventions that we could do for our production enhancement, right from the completions, our lift mechanisms. Refracturing is very common in CBM. We have been doing that, and we are getting very initial results, which is positive. So it's a long campaign. So we are trying out different type of fracturing mechanisms or propants. Drilling. We have drilled inclined and deviated wells as on date today, but as I said, we are operating in an on-land area, habitat area, forest area. So for us, pad imprint is very, very important. So we are trying to now moving ahead into horizontal wells. Our colleagues, our peers have done that, and we are really excited the way they have done it. So we are trying to go ahead with horizontal drillings ourselves as well. That will come in the next phase of development. And another thing which we are very keen, and we have already started with TERI and a few other organizations, is microbial. So that's again another thing which has good potential in CBM. So we're going to start that this month, I would say. Touch wood, this month itself we are going to put that. And also we have been pushing hard on some chemical treatment. That also we have got mixed results as on date today, but we have not given up. We are going to try further more chemical treatments. So to cut a long story short, in CBM the solutions are non-unique, and it takes time to understand that sometimes preemptive maintenance is not good for CBM. You know, you leave the well actually when it's operating at its peak and only treat it when it breaks down. Unlike in conventionals, you do a lot of machine learning and artificial intelligence to map that when your pump is going to fail, so better change it or do maintenance. So keeping all this in mind, what I'm trying to push also here is to utilize digital as much as possible, but in the last session or the session yesterday, I heard, no, sir only told, sir, you told very nicely that how can we get more oil from digital? It's a very good question, and I believe digital is a great tool. It's a great tool. We have to solve it here. You know, the concepts are all in our head. So if we understand that and then utilize digital as much as possible to cut our journey short or make it faster, I think that's is going to give us. But for discovery, sir, we have to go back to old geologists, geophysicists, and reservoir engineers. They have to get to find the new fields. But digital is going to help us a lot on that. I'm sure of it. I am, I am in my late 40s, so I'm not in that stage. At the same time, so for me, digital is a great tool if I utilize it sensibly and responsibly. Thank you. That's what I wanted to share. Thanks for your patience here.